In this example, we're dealing with a car that is slamming on its brakes. The brakes provide a deceleration of 2.3 meters per second squared, and it takes 15 seconds for the car to stop. And the question is, what's the car's initial velocity? Now, why is the acceleration listed as negative? Well, think about it. The car is slowing down, so the acceleration is opposing the velocity. If I want the velocity to be positive, then the acceleration must be negative because the acceleration is opposite the velocity. How do we solve the problem? Well, remember, equation 2.6 relates velocity, acceleration, and time. So we'll use equation 2.6. V equals V naught plus AT. What's V? Well, remember, V is the final velocity. The final velocity has to be 0 because the car is stopped, so V is 0. V naught is what we're trying to find out. That's the initial velocity. Acceleration is negative 2.3 meters per second squared, and time is 15 seconds. So that's my equation. 0 equals V naught plus negative 2.3 meters per second squared times 15 seconds. Now all I have to do is solve for V naught. That's not too bad. If I subtract V naught from both sides, it cancels on the right-hand side and appears on the left-hand side as negative V naught. Now look at what we have. We have a negative on both sides of the equation. The negatives cancel. So our final equation is V naught equals 2.3 meters per second squared times 15 seconds. When we multiply the units out, the seconds squared, the squared part cancels with the seconds on 15 seconds. And when we multiply the numbers out, we get 35 meters per second. The answer can have only two significant figures because both 2.3 and 15 have two significant figures, so that's why the answer is 35 meters per second.